Hey everyone, and welcome to day 2 of distance learning. So yesterday we covered trapezoids, isosceles trapezoids, and we started looking at properties of parallelograms. On to the next round. So we're going to start looking at properties of rectangles and of rhombi. So that's the plural for rhombus. We're going to also try and look at, how do we answer some algebraic questions about different types of quadrilaterals. So how do you take the properties of a quadrilateral and use it to answer a question? This will help you with your poster and will also kind of give you an insight into the kinds of questions that you can expect to see in the quadrilaterals unit. Essential questions for today: what are the steps I should go through in answering a question about a quadrilateral? So, how do I approach this? What are the properties? What property would apply to this particular question? And then how do I go and solve it? And what are the properties of rectangles and rhombi? So can you recall them? Can you use them? Okay, so here's where I left you yesterday. I said, here is one proof, and I want you to try and figure it out on your own, and I'll give you the solution to that. So let's go through what the solution to this proof would look like. The given is that the opposite sides of the quadrilateral are parallel, and we want to try and prove that this results in the diagonals bisecting each other. So one thing that we're going to have to try and do is show that the triangle here and maybe here are congruent to one another, or you could try and prove that triangle 3 and 4 are congruent. It doesn't really matter which one you do, as long as you show that an opposite pair of triangles are congruent. That way we can say that the parts would be congruent and then be able to prove that the diagonals bisect each other. To do that, though, we are going to need opposite sides to be congruent. So that's where we're going to start. We're going to have to do this in almost a two-part proof. So given we have got AB is parallel to CD. Try and put the second one in here. We've got BC parallel to AD. And that is our given. That's all we got, parallel. Should be a hint to you. If we're given parallel lines in a proof, typically that means you're going to have to try and prove that there are corresponding angles, alternate interior angles, alternate exterior angles that are congruent. Usually we don't see much in terms of same side interior angles because angles being supplementary doesn't usually help us prove congruent shapes in any way. So as we look at this, what I'm going to try and do is prove that triangle ABC, so that top left-hand side, is going to be congruent to the one across from it, ADC or CDA. So if I can prove those two triangles are congruent, I'll be able to show that the opposite sides are congruent as well. All right, so first one, we're going to say that angle BCA is congruent to angle CAD, and that is alternate interior. So we've got those alternate interior angles, and then if we go to the other angle, they are also congruent by alternate interior. So because we have parallel lines going both ways. All right, so that would be angle BAC. And again, apologies for the bad handwriting. I'm still learning to write using this tablet. And angle ACD. Also alternate interior angles. All right, so now at the moment we have got two angles common in both. We have that line AC that runs up the middle between the two of them, so we're going to use that as our side. So AC congruent to AC. If something is equal to itself, that is the reflexive property. So hopefully we are brushing off some cobwebs from this break as well. So now we've got a side common to both, and we've got two angles. So we have angle, side, angle in both triangles. So we'd say triangle ABC is congruent to triangle CDA, That's angle, side, angle. All right, I'm going to erase some of my markings here so we can see this again. Okay, so what we need now is we're going to try and prove that this triangle here and this one are congruent. I'm actually going to erase my previous part of my proof, so I just have enough lines to do this. So we've shown that the triangles are congruent using angle, side, angle. I'm going to kind of come back up to this part. All right, so triangles congruent by angle, side, angle. We know that's true now. We also would say, all right, the angle in here will be congruent to the one down here, same reason, angle, side, angle. So I'm going to go back to that point. So angle CBD congruent to angle ADB. And that is once again alternate interior. So now I've got two angles congruent in that top triangle and the bottom one, triangle 1 and triangle 2. We also can say that BC is congruent to AD, and the reason we can say that is CPCFC, because we showed that the triangle ABC and triangle ADC were congruent. So corresponding parts must also be congruent. So that means that triangle, now the little one up top would be triangle BCE. And that triangle is congruent to triangle, let's get our letters right, so DAE. And we again have angle, side, angle. And then finally, we can say, all right, well, if that's true, then that means BE must be congruent to ED, because they're in the corresponding position, and CE must be congruent to AE, corresponding position. So BE congruent to ED, and AE, that's an E, congruent to CE, and this is CPCFC. So really long proof. I probably, if I was to do this again, I would just say, let's give that the opposite sides were also congruent to save us from having to prove that first part again. But you know, it's not bad practice to go and do a longer proof like that where you have to show multiple things are true. It's the kind of question I could ask you very easily in a test of some sort. Okay, so I kind of want to bring up this quadrilateral classification tree. So this shows how the shapes are related to one another. What we have looked at so far, we've said, okay, quadrilaterals, four-sided figures. That's pretty much all you get to qualify as a quadrilateral. Four-sided closed figure, 360 degrees is the sum of the interior angles. We talked about trapezoids. So trapezoid is the first level of classification for a quadrilateral. So that is the top and bottom, or any two, opposite sides. So one pair of opposite sides are parallel. If you can also get the other two sides to be congruent, you have an isosceles trapezoid, which has a couple more properties, again, a little bit more complex. And we finished up with parallelogram. So in parallelograms, the opposite sides were parallel, opposite sides were congruent, and diagonals bisected each other. So those were kind of the key things that we noticed about a parallelogram, and the opposite angles being congruent as well. Next shape up for us is going to be rectangles. Properties of a rectangle. If you have notes in front of you, this is when you are copying down a couple of notes again, making sure that you have all your properties and you're ready to make your poster for this when you are done. So properties of a rectangle. We got the four sides. So anything in green are properties that are true for shapes above it in the classification tree. So like trapezoids, isosceles trapezoids, parallelograms. And then opposites parallel, also true of parallelogram. Diagonals bisect each other, still a property of a parallelogram. Now we start getting into what makes a rectangle unique. So it has all the things a parallelogram has, plus the 4 angles are 90-degree angles, so the adjacent sides are perpendicular. The diagonals are also congruent to one another, so they're equal in length. That's different to a parallelogram. In a parallelogram, you have a longer and a shorter diagonal. You also get 4 congruent right-angled triangles out of this. So each corner making up the corner of a right-angled triangle and the diagonal completing it. You have 2 lines of symmetry. So that is going through the bisectors of, the midpoints of each of the opposite sides. So if you connect the midpoints of the opposite sides, you would get lines of symmetry. And 1 rotational symmetry, if you rotate the shape 180 degrees, it will rotate onto itself. So those are the properties of a rectangle. So making sure that you've got all those, you can see where they are. If you have questions, please post it in the class discussion to let me know. And let's start taking a look at what a question for a rectangle might look like. Pause the video at any point if you need to just slow it down and write. All right, so here's a proof for a rectangle. If a quadrilateral is a rectangle, then it's a parallelogram with congruent diagonals. So we're going to try and prove that the diagonals are in fact congruent to one another. So given opposite sides are congruent, so we got BC and AD congruent, AB congruent to CD, and they are also parallel to one another. And all angles are congruent, which is already marked in for us. So we've got a lot of givens in this one. We've got BC is congruent to AD. And we've got AB congruent to CD. And then we've got BC is parallel to AD, and AB is parallel to CD. That's given. And then we'll also say angle A is equal to angle B is equal to angle C, which is equal to angle D, which is all equal to 90 degrees. And that's given. All right, so now to get started. If we look at our shape down here, we've got 4 right-angled triangles. We've got 4 smaller triangles where the opposite ones are congruent, kind of like our parallelogram question earlier. We're going to try and prove the diagonals are congruent, so you need to use triangles that use the entire diagonal. So I'm going to use the triangle from A, B, C, and then connect it all the way back down to A. So that's my first triangle. The other triangle I'm going to use, I could use the one across from it, I could use the one adjacent to it. It doesn't matter as long as the diagonal BD is used as well. All right, so if we say triangle ABC, we know AB, BC, and the angle B are all congruent, and it would be congruent to triangle A, let's say DC. So in angle A's position is C, and then we've got D, and then we've got A. So why is that true? This is side angle side. Even though this is a right angled triangle, it's not a HL property because we don't know the hypotenuse. So it's just a standard side angle side, even though it is a right angled triangle. I know that's one of the things we look for usually when we are trying to figure out which criteria to use. If the triangles are congruent, then all pieces must be congruent. So we could say, all right, well, that means BD must be congruent to AC, and that is CPCFC. So really you could have used 2 lines for the given, but we did just fine with 4. All right, so now we're into the algebraic stuff. What I want you to do here is push pause, try and solve it yourself before letting me go through it. I'm just going to go through it as if you had already pushed pause. So what we got, PQRS is a rectangle, solve for the value of X, Y, and Z. And just in case you need clarification, what the different angles or side lengths are is written on the right as well. So I'm going to start with, let's start with X. So up in the top left-hand corner, we know the full angle P is a right angle, which means that those two must add up to be 90 degrees by the angle addition postulate. So that would mean 3x plus 8 plus 10x minus 9 is equal to 90 degrees. So 13x and 8 minus 9 is minus 1. Add that 1 to both sides. So we get 13x is equal to 91. X is 91 over 13. X is, so 91 divided by 13 is 7. So there's our first solution. X is 7. Moving on to, let's go with the 4y plus 1. So that is the hypotenuse or the diagonal of the rectangle, which will be the hypotenuse of this triangle, where one side is 15, one side is 8. So we know if we set this up using Pythagoras' theorem, we should be able to figure out the value of y. So I'm just going to solve for what the length of that hypotenuse should be. So 8 squared plus 15 squared is going to be equal to that hypotenuse squared. So 64. So 8 squared plus 15 squared. So 64 plus 225 is 289. So 289 is going to be c squared. And the square root of 289 is 17. So 17 is equal to c. So we did square root of both sides to get the square to cancel. So 17 is the length of my hypotenuse. So that should be equal to 17. So 4y plus 1 is equal to 17. Well, that's a nice easy one. So we'd subtract 1 from both sides. 4y will be equal to 16. Y must be 4. So there's that second solution. All right, and then we go into the last one. So 5z plus 3 is this little angle in the center here. And we have to figure out, okay, how do we solve for that? Well, one thing I know is it's got to be, so these triangles are isosceles, and it's got to be the same as the angle on the other side. And if the triangles are isosceles, that means that whatever the angle was up here is going to be the same as the one down here. So angle TSP is going to be the same as angle SPT. So that's the definition of an isosceles triangle. So if I substitute in for x and figure out how big that angle is, I should be able to solve for the missing angle. So x we found was 7. So 10 times 7 minus 9. 10 times 7 is 70 minus 9, so that would be 61. So that means this is 61. 61 plus 61 is 122. So this is going to be 180 minus 122. So we got 58 degrees is going to be equal to 5z plus 3. Excuse my bad grammar here. Let's get rid of that. So 58 equals 5z plus 3. Subtract the 3 from both sides. 55 is equal to 5z. Divide both sides by 5. And we get 11 is equal to z. So that is a kind of question that I would ask you very easily on a test, quiz, that sort of thing, where you are being asked to apply the properties of a rectangle to solve a question. Now the hard part is if you do not know your properties, you get stuck because you are not able to move forward because you need some piece of knowledge to help you get going. So it is really important in this unit that you actually study the properties, make sure you know them, you can use them, and so on. Flashcards and of course our posters are going to be a big help for this. All right, here's another one. And this is a kind of question that I want you to really think about because it's going to come up potentially on a benchmark if we ever do get to take a benchmark for this course. So we've got 8, we've got x, and we've got x plus 4. all part of a rectangle and of course another right angle triangle. So we know that normally we would solve this using something like a Pythagoras' theorem, but the problem is there's x's on two sides. It doesn't stop you. Set it up the exact same way. So 8 squared plus x squared is equal to x plus 4 squared. And we do have to call on some Algebra 1 temporarily because this is a binomial that is being squared. So two terms that get squared, you have to make sure you do that properly. This is your distribution property, or some of you guys will know it as FOIL. So x plus 4 squared is actually, so we're going to kind of work on this for a second. This is x plus 4 times x plus 4. So that is everything in the first bracket times everything in the second bracket. So there's going to be 4 different terms in our answer. So x times x, x squared, x times 4, 4x, 4 times x, another 4x, and 4 times 4, 16. So this is going to simplify to be x squared plus 8x plus 16. Let's go back to our original. So we had 8 squared, 64, plus x squared is equal to what we solved for earlier, x squared plus 8x plus 16. So now this is where it's like, okay, we're not actually solving a quadratic here because we can subtract subtraction property equality, x squared from both sides, and they cancel. So there's no x squareds in this. It's actually easier than it looks. So that means we're left with 64 is equal to 8x plus 16. Let's subtract that 16 from both sides, get all the numbers together. So we've got 8x is equal to 64 minus 16, which is 48. Divide both sides by 8. X is 6. So this is one where you're going to have a little bit of work to do in order to be able to solve this, and you need to remember your Pythagoras' theorem and then also distribution property from Algebra 1. If that's something that's rusty for you, go do a quick Google and say, I want to practice doing distribution of binomials. That would be a good search term. I will try and post some practice for that in our Schoology page as well. All right, so we have gotten quadrilaterals, trapezoids, isosceles trapezoids, parallelograms, rectangles. Next up for us, we're going to skip over to the opposite side, rhombus. And you notice that our classification tree has actually split. So rectangles and rhombi are going to both have properties of parallelograms, but they are distinct shapes from each other. They're different. So let's see. All right, so we got rhombus here, and you can see the diagram is already given to us. Let's start picking out those properties. So the 4 sides are congruent. This is actually a unique property for a rhombus. So we didn't see that in parallelograms, we didn't see that in rectangles or any of the other shapes so far. The opposite sides are congruent. Still, that's mean if 4 sides are congruent, the opposite sides are congruent as well. That's a property from our parallelograms. The opposite sides are parallel, still true. Opposite angles are equal. We saw that in the parallelogram as well. Diagonals are perpendicular. That's a new one for us. We haven't seen that one yet. The diagonals bisect the angles of the shape. We did not see that one yet either. And then it forms 4 congruent right angle triangles. So you can see where the little right angle is given at the center of the shape. Those are your 4 little right angle triangles. And then you would also have 4 other isosceles triangles given to you as well. 2 lines of symmetry. If you actually reflect over the diagonals in this case, because they are perpendicular and an equal distance on both sides, you will actually reflect onto itself. So there are 2 lines of symmetry, and those are on the diagonals. And then you still have 1 rotational symmetry. So once again, pause the video if you need to in order to get your notes taken down. All right, here is a practice question for a rhombus. So ABCD is a rhombus. Solve for the value of x and y, and then round your answer to the nearest hundredth if needed. So you'll start noticing that because we are dealing with shapes that have right angles, we're going to have a bit more Pythagoras' theorem popping up. And unless the numbers used are a Pythagorean triple, so that's where all 3 sides of a right angle triangle are whole numbers, you're most likely going to get a radical, so a square root answer, which when you solve it out, you get a decimal. All right, so looking at this one, pause at this point if you're going to solve it on your own, which I encourage you to do, and then just unpause when you're ready to see what the answer is. So we've got all sides in a rhombus are congruent. So that means that we can use the two x values and put them equal to each other because they should be congruent to one another. So 12x plus 15 is equal to 8x plus 27. Subtract 8x from both sides and subtract 15 from both sides. So 12x minus 8x is 4x, and then 27 minus 15 is 12. Do our division, x is 3. All right, so that was a nice easy one. X is 3. This is a perfect kind of question that you could have on your poster as well. So you know that all four sides of the rhombus should be congruent, and this is kind of a unique one because the adjacent sides are congruent as well. So now, y is the full length of the diagonal BD. We want to solve for that. So what we need to think about here is that there is a right angle where the diagonals meet. And that's why this 14 is given to us, so the 14's on both sides. So if we know x is 3, so what's that? 8 times 3 plus 27. 8 times 3 is 24. 24 plus 27 is 51. So the length of the hypotenuse is 51. Other side's 14. We can figure out what this side is, and then if we double it, we'll get the hypotenuse. So let's start our Pythagoras theorem. So 14 squared plus, I'm just going to call it b squared is equal to 51 squared. It's going to be some big numbers. All right, so that would mean that b squared is going to be equal to whatever 51 squared is minus 14 squared. Let's do that. So 51 squared is 2,601 minus 14 squared. So our answer, b squared is equal to 2,405. And then to get b on its own, we're going to square root both sides. So square root of that answer, 2,405, is 49.04. Now, I don't want to round just yet. So what I'm going to do is I'm going to put a bunch of decimal places in here because we want to round at the latest possible moment. So 0.4079934. So if you put at least 7 or 8 decimal places, you'll be fine when it comes to the end. So if this was that value we saw for b, the full length of BD is going to be double it. So we're going to multiply this by 2, and that's when I want you to just take your calculator, hit multiply by 2, and then we'll round to that final answer. So it doesn't really change much because the numbers, it was already so close to 49, but BD, or y, is going to be equal to 98.081, and that will round to be just 98.08. So again, if you have questions about that, please post in the class discussion. All right, so that brings us to an end for today. We're just under 30 minutes. What are the steps I should go through when answering a question about a quadrilateral? A, what shape am I given? And what do I know about the shape? So you can look at the diagram and be like, oh, that's a rectangle, that's a parallelogram. But unless it's given to you in the question that the shape is a particular shape or that there are properties present, you cannot assume that it's true. So you go based off of your given information, and then you start applying properties that you know exist from there. Look for relationships between the sides, between the angles, between the diagonals. Properties of rectangles and rhombi, I mean, you can go back through the list, but rectangles, the key things, the diagonals are congruent. You've got 4 right angles, and it's opposite sides still congruent, opposite sides still parallel. For a rhombus, the diagonals are perpendicular, all 4 sides are congruent, and the diagonals bisect the angles. Those are kind of key properties that I would look for. All right, so some things for you to work on. I've posted a Khan Academy, which is a kind of unit test style Khan Academy. It'll recap on some of our congruent triangle stuff, as well as some of the new quadrilateral stuff, and then continue on with your poster. So you have 2 new shapes now that you can add in. So far you should have trapezoids, isosceles trapezoids, parallelograms, rectangles, and rhombi. So making sure you have posters for all of those. Tomorrow we will finish off with kites and squares. All right, if you have any questions, please post it on the class discussion, and I will see you tomorrow.